let's consider nuclear physics. Now, when we are talking about nuclear physics, we are simply studying the nucleus of an atom. We know that an atom has got three basic parts. First, we know that it has got the nucleus, and in the nucleus, that's where we find positive protons and also neutral neutrons, meaning these neutrons they don't have any charge. And then we have got shells which are around this nucleus, and in there we find electrons. Okay, like that. So different reactions are going to get to happen here such that you can be able to lose electrons or even gain these electrons. Now one thing that I want us to see is that the nucleus has got neutrons which are positive, I mean neutrons which are neutral, and then protons which are positive. And then the shells have got electrons which are negative. So electrons are going to be moving around the shells because they are attracted to the nucleus by the positive protons. Now when we are discussing nuclear physics, we are simply talking about these different kinds of nuclear reactions which get to happen. So when two atoms, let's say hydrogen, gets to react with another hydrogen, like they get to mix, that is going to be called fusion. And fusion, mostly this reaction is even going to like produce energy like that. Okay, or you can have hydrogen which is bonded to hydrogen, this breaking, and that is going to be called fission. So fission is where a bond gets to break or a substance gets to break, while fusion is where the bond gets to come together. Now in here I'm going to talk about three different particles that are able to be emitted when a bond gets to break. Okay, I'm going to talk about beta particles, alpha particles, and then gamma rays. These are some of the particles which are able to be released when a when a particle gets to fizz, that means it gets to break. Now let's start with alpha particles, which we can also call alpha rays. When we are talking about alpha rays, what really are these? So alpha rays, these are simply helium nucleus. So an alpha ray is just a helium nucleus consisting of two protons and two neutrons. How is this? Meaning that this alpha ray is something like this. We know helium has got two protons, and then it has got a mass number of 4. So this is what we call an alpha ray or an alpha particle. What of a beta particle or a beta ray? So when we are talking about a beta ray, these are simply electrons. Okay, these are simply fast moving electrons. They've got really a high speed. So these you see we can just represent them as E. The mass of electrons is very small, so these we consider the mass as 0. Like the mass is negligible, it is too small, right? Like that. Now electrons, we know that they are negatively charged. And we also have gamma rays. So the symbol for gamma we can use, mostly will not even be able to use the symbol, but it looks like a Y. So those are gamma rays. Now what are gamma rays? So gamma rays, these are just electromagnetic waves which are consisting of photons. So photons are simply, I can see just like a human being is made up of cells, light is also made up of photons. Just like almost everything is made up of matter, so also light is made up of photons. So this is simply a unit of light. Now light is part of the electromagnetic waves. Light is part of the electromagnetic waves. So what are electromagnetic waves? These are waves which get to move at the same speed, and they have got similar properties. For example, they have got wavelength, they have got frequency, and then they have got also a speed. And we can calculate the speed by saying wavelength times frequency. electromagnetic waves all move at the speed of light, which is 3.0 times 10 to the power 8 meters per second. So basically these are the rays which we have. So this tells that when we have got a substance, it gets to break by releasing an alpha. Let's say it releases an alpha particle. What gets to happen? What does it really get to release? So when a substance breaks and releases an alpha ray or an alpha particle, basically uh, it is releasing an helium atom. For example, let's say we have got an element X, okay, which has got a mass number of, let's say, 20, and then it has got, let's say, 6 protons. So if this one undergoes an alpha decay, what is going to happen when it undergoes an alpha decay is that it's going to release helium, that is H with a 2 with a mass number of 4. So now you can find out what substance has been formed or what substance has been produced. So it has 6 protons, but now it has lost 2. So how many are going to remain? Let's say the substance which is formed is Y. So it is going to remain with now 4 protons. It had the mass number of 20. Now we remove the mass number of what has remained is 16. So this will be the new atom that is going to be formed. That is after an alpha emission. Let's say it also undergoes another alpha emission. What is going to happen? Again, remember, if it undergoes, this one again undergoes an alpha emission, is going to release an helium which has got 2 protons and a mass number of 4. So what will remain? Let's say what remains is Z. So from this 4 we're going to remove 2 to see what remains. So we have got 2, and then from 16 we are going to remove 4 to see what remains. We are going to have 12. So if this element releases 2 alpha particles, it is going to end up with this one which we are able to see at this position. So this is basically that gets to happen. We can give various examples to see what is going to be seen. Let's say we have got oxygen. What element is it going to turn into if it releases an alpha particle? We know oxygen has got a mass number of 16 and a proton number of 8. So if this one releases an alpha particle, what is going to happen? We are going to have, of course, the same alpha particle released here with a mass number of 2, mass number of 4, proton number of 2. Now what is going to form? From the oxygen we've released 2 protons. From the 8, how many are going to remain? We are going to have 6 remaining. And then from the 16 we've released 4. How many are going to remain? We are going to remain with 12. So what element, let me call this X, what element has got 6 protons and then it has got a mass of 12? So the element that is going to result is carbon. If we check on the periodic table, carbon has got a proton number of 6 and a mass number of 12, meaning that if oxygen undergoes 1 alpha decay, is going to form carbon. Right, so that is an alpha decay basically. What of a beta decay? What kind of equation are we able to see if a compound releases a beta particle? So when a compound releases a beta particle, what we're going to see is that, let's say this is compound X, which has got, let's say, a mass number of 6 and a proton number of 4. Now we know that basically a beta particle is an electron, right? So it is an electron. So we know that an electron is basically negatively charged, right? So when we get to release an electron, what is happening here is the mass does not change when we release a beta particle. The mass does not change. So we are releasing a beta particle. We are going, let's say we remain with Y, the mass will still be 6. Okay, like that. Now what is going to happen to this is that we are going to have, from 4 we are now going to have a 5. Okay, like that. And then we are going to say plus, an electron, which is a beta particle, which is also a product. We know an electron is negatively charged. It has a mass of 0 and it is a negative 1. So what is really happening here for us to have this thing which we have like this one? I can make us, let's say, let's consider on the reactant side. How many protons do we have? From this number, this means that we have got 4 protons. Okay. Now we know the mass number is 6. So how many neutrons do we have? Neutrons, we'll just say 4, we remove from 6, that will remain with the neutrons, and that is 2. And then we can also find out electrons. You know that in an atom like this one, the number of electrons is equal to the number of protons, that will still be 4. But what we're able to see this side is that the protons are now what? The protons are now 5. Okay. And then the neutrons, we'll say 6 minus 5. That is going to give us a 1. And then the electrons, you know the electrons are supposed to be the same as the protons, isn't it? So this is basically a 5 here. So what can we be able to deduce from this reaction? So when we have got a beta reaction, what basically we see is that the proton number is going to increase by 1. The proton number increases by 1, then we have got a beta reaction. So that is something that we are able to determine from here. For a beta reaction, the proton number is always going to increase by 1. What happens to the mass number? The mass number does not change. The mass number does not change. Now, when we get to look at a beta particle is negatively charged. So we know that electrons are negative. Protons are what? Protons are positive. So when you get to release this beta particle, is going to attract a proton. So we are seeing the increase in the number of protons because the beta particle has got high affinity. Okay, beta particles are high energy electrons. Okay, they've got that energy, they have higher energy like that. So this is the kind of reaction that we're able to determine from beta particles. Let's consider an example. Let's say we have got iodine, and iodine has got a mass number of 131, a proton number of 53. If it undergoes a beta reaction, what atom is it going to result into? Now we know that for a beta reaction, basically we are going to have an electron as a product, and another thing that we know is that the mass remains unchanged, but the proton number is going to increase. So we are going to have 131 still, but here we are going to have a 54. Let me call it X. So we are going to go on the periodic table, we check what has got a proton number of 54. Because when you are determining what kind of element you have, you get to look at the proton number. So if you check on the periodic table, something with a proton number of 54 is xenon. So meaning that this, when iodine undergoes a beta emission, is going to form xenon, or is going to change to xenon. So basically, this is the kind of reaction that we are able to determine from here. Right. So maybe we just consider another example to just make sure that we are good with this one, and then that is going to be it. Let's say we have got carbon. We know carbon has got a mass number of 6. Let me use the isotope of carbon that has, not a mass number, a proton number of 6. Now let me use the one which has got a mass number of 11, and then it undergoes a beta emission. What are we going to see? Of course, an electron like that is going to be a product. Now the mass is going to increase by 1. So we are going to have, the proton number is going to increase by 1. The mass number remains the same. So on the periodic table, what substance or what compound has got a mass number of 6? I mean 7. So just get to go on the periodic table, we check that which has a mass number of 7, and that is going to be the one. And this should be a nitrogen with a mass number of 7. So basically this is how you get to determine when a beta particle is released. Alright.